Often overlooked in favor of its brighter neighbors, Mercury may hide secrets that challenge our understanding of the solar system. Recent data from the James Webb Space Telescope suggests that Mercury may have had life forms in the past. This unassuming planet may be completely different from what we have long believed, and it hides amazing discoveries before our eyes. The study of Mercury has always been considered nearly impossible and dangerous for reasons we are only now understanding. Mercury, hidden at the center of our solar system, has rarely been the subject of groundbreaking discoveries. But recent observations by the James Webb Space Telescope lead scientists to suspect that Mercury has secrets that have remained hidden until now. Mercury, a rocky planet slightly larger than Pluto and significantly smaller than Earth or Mars, was previously thought to be too hot for life or vegetation. However, scientists have found bodies of water in Mercury, which will drastically change our understanding of this world. Mercury is not the hot world we once thought. Large basins such as the Caloris Basin, which is more than 1,500 kilometers in diameter, are striking landscapes. Scientists call these structures, which can be several kilometers long and up to 3 kilometers high, rocks. Other typical Mercury landscapes include hollows, small clear depressions that are probably formed by the sublimation of elements such as sulfur and potassium. The poles of Mercury have craters that are constantly in shadow, keeping them cold enough to hold water ice. This discovery is absolutely amazing because scientists have long thought that Mercury is too hot to sustain water permanently. The actual temperature of Mercury quickly reveals a world of extremes. Despite these extremes, Mercury is by no means a boiling hot inferno like Venus. Temperatures vary, reaching 427 degrees Celsius during the day, but falling to approximately -173 degrees Celsius at night. Scientists attribute these extremes to the planet's almost non-existent atmosphere, which cannot store or dissipate heat. Meanwhile, Venus has one of the densest atmospheres in the solar system, creating a greenhouse effect that heats the planet up to 467 degrees Celsius day and night. Mercury, on the other hand, shows that it may have temperate regions, raising the tantalizing question of whether life could exist in such fringes, in shadowy craters, or beneath great escarpments and hidden cliffs. Discovering the world of aliens hidden behind the eyes is amazing. The Greeks were able to discover this relatively small world as early as 265 BC. On the scale of our solar system, Mercury is like a pin-sized, visible only in simple telescopes when it passes in front of the Sun. The Greek astronomer Tis was the first to record the position of a planet in the sky. But only with the advent of modern telescopes in the 17th century could astronomers make more detailed studies and better classify Mercury. In 1631, the French astronomer Pierre Gassendi was the first to describe the passage of Mercury in front of the Sun and to calculate the orbit of the planet. In 1771, German astronomer Jan Hermann Schurz studied the orbit of the planet, but mistakenly thought that the orbit of Mercury is related to the Sun, as the Moon is to the Earth. This misconception lasted until 1859, when French astronomer Urbain Le Verrier noticed anomalies in the orbit of Mercury that could not be explained only by the gravity of other known planets. He hypothesizes that a previously unknown planet called Vulcan exists between Mercury and the Sun. Although the existence of Vulcan has never been demonstrated, Albert Einstein's theory of general relativity explained the anomalies in the orbit of Mercury in 1915 and ended the search for Vulcan. Amazingly, we have had detailed maps of Mercury's surface since 1974 thanks to the Mariner 10 spacecraft. This probe revealed the smallest details of Mercury's surface with unusual sharpness. A NASA probe has flown very close to Mercury 3 times and taken the first close-up views of the planet. Those images showed craters and landscapes and provided measurements of the planet's environment that showed Mercury has a thin helium and hydrogen exosphere and a weak magnetic field, which is surprising given the planet's small size. After the 1970s, the search for Mercury was stopped. NASA cited difficulties in building and navigating the probes due to the Sun's gravitational pull and extreme conditions. However, in 2008, NASA launched the Messenger mission, which successfully reached Mercury's orbit in 2011. By 2015, Messenger provided new insights into the geological history of the planet, including evidence of volcanism, vast lava plains, and water ice in polar craters. This evidence showed that Mercury was and is geologically very active, suggesting that we may have misjudged its past. Some scientists believe that Mercury was once elsewhere in the solar system and then Jupiter's gravity pushed it closer to the Sun. If Mercury was once in the habitable zone, there could be life there. Some of the landscapes on Mercury resemble rocky worlds like Earth or Mars. It is possible that Mercury was once temperate. The James Webb Space Telescope sheds light on these questions. By looking at planets like Jupiter and Uranus, scientists have gained new insights into the gas and ice giants. They hope to do the same with Mercury by using special filter techniques to scan the Sun around Mercury. The James Webb Space Telescope is practically designed for this task because it was built to capture even small exoplanets that pass in front of these stars. In our own solar system, tiny Mercury in front of the giant Sun is like a tiny dot. The telescope detects minimal fluctuations in light and clearly distinguishes the light reflected by Mercury from the light coming from the Sun. If successful, we will obtain even more detailed information about the chemical composition of Mercury's surface. Scientists hope these scans will reveal whether Mercury really is lifeless, or whether there are structures and features we've previously overlooked. Further evidence of the presence of water on the planet would be a sensation, forcing the scientific community to recognize Mercury as a much more complex and mysterious world than previously thought. Often overshadowed by its more visible neighbors, Mercury held surprises that continue to fascinate scientists. In addition to extreme temperatures and a thin atmosphere, recent observations have revealed complexities that challenge our understanding of this tiny planet. Mercury has evidence of a turbulent past characterized by volcanic activity and tectonic movements. The planet's surface is scarred with many impact craters, suggesting a history of heavy bombardment. Caloris Basin, a huge crater more than 1,500 kilometers in diameter, bears witness to these ancient cataclysms. These craters are surrounded by large plains, probably formed by volcanic eruptions that once shaped the landscape of Mercury. These geological features provide insight into the evolution of the planet and raise questions about its internal processes. Mercury's proximity to the Sun affects its environment in unique ways.
The thin outer sphere of the planet consists mainly of helium, hydrogen, and minor amounts of other gases. Unlike Earth or Venus, Mercury lacks a significant atmosphere to regulate its surface temperature. This results in extreme temperature swings, with daytime temperatures rising to 427 degrees Celsius and nighttime temperatures dropping to a chilly -173 degrees C. Such extreme conditions challenge the survival of all possible life forms, but recent discoveries of water ice in the permanently shadowed craters of Mercury's poles have intrigued scientists. The presence of water ice on Mercury is particularly important. The polar regions of Mercury, long thought to be too hot to store water, provide a cold trap where water molecules can accumulate and persist indefinitely. This discovery expands our understanding of Mercury's composition and raises the possibility of resources that could support future research. Regarding the orbital dynamics of Mercury, its proximity to the Sun gives it an exceptionally high orbital speed of about 47 kilometers per second. Mercury makes a complete revolution around the Sun in just 88 Earth days. This rapid movement combined with slow rotation on its axis creates a unique pattern of day-night cycles and solar radiation. Searching for Mercury has been a challenge for space agencies because of its proximity to the Sun. The Mariner 10 mission in the 1970s provided the first close-up views of Mercury's surface, revealing its crater-like landscape and geological diversity. Subsequent missions, such as Messenger, increased our understanding by mapping the planet's surface and studying its magnetic field and outer atmosphere. The James Webb Space Telescope, JWST, promises to change our understanding of Mercury. Equipped with advanced imaging capabilities, JWST will allow scientists to study the composition of Mercury's surface in unprecedented detail. By observing Mercury's transit across the Sun, JWST will analyze the characteristics of the planet's atmosphere and surface, providing new insights into its geological history and its potential to store water or other volatiles. The discoveries made by JWST could change our understanding of the formation and evolution of Mercury. By comparing the properties of Mercury with those of other rocky planets in our solar system and beyond, scientists hope to discover universal principles that govern planetary development and habitability. Despite its harsh environment and small size, Mercury continues to surprise us with its geological diversity, orbital dynamics, and ability to hold water ice. Future missions and advances in space observation technology promise to reveal more of Mercury's secrets and offer new perspectives on the evolution of terrestrial planets and the conditions necessary for life.